All right, let's get into it. Today, we're going to pull back the curtain on how video games are actually made. We're going to look at the tools and the language that take an idea from just being in your head and turn it into an interactive world you can actually explore and play in.
I mean, come on, who hasn't? Whether it's this huge 3D adventure you've been dreaming up or just a cool little 2D puzzle game, that desire to create is probably why you're here. The big question is always, okay, but how do I actually start? Well, that's what we're going to tackle.
Okay, so first things first. Before we can build the house, we need to understand the foundation. And in game development, that foundation is the game engine. We're going to start with what Unity is and why it's the go-to for so many people, from indie developers in their bedrooms to massive AAA studios. So try not to think of Unity as just a program on your computer. It's more like a digital workshop, a creative playground. It's a real-time engine, which basically means you see your changes happen instantly, no waiting around. And man, is it flexible. You can build a game for your PC, your phone, a VR headset, you name it, all from the very same project. Its secret sauce is a really simple but totally brilliant idea, a component-based architecture. Every single thing you see and interact with in a Unity game is something called a game object. Your hero? That's a game object. The camera that's following the hero? Also a game object. The ground they're walking on, the trees, the enemies, all game objects. The actor on a stage analogy is perfect. They're like the nouns in your game's world. But here's the catch. On their own, they're just empty shells. They don't do anything, yet. And this is where the magic happens. Components are what you attach to those empty game objects to bring them to life. So if the game object is your actor, the components are its abilities, its props, its costume, and its lines. You can add a rigibody component to make it fall with gravity, a collider component so it can't walk through walls, and, most importantly, a custom script component to give it all the unique behaviors you can dream up. So we've got our game objects and our components. Where do we actually put all these pieces together? Well, that happens inside the Unity editor. This is your digital toolbox. It's the whole workshop where you'll assemble everything. Now, it can look a little intense at first, I know, but once you know what you're looking at, it's actually laid out very, very logically. These 5 windows right here are basically your command center. You'll build your level visually in the scene view, kind of like you're playing with digital Legos. Then you can peek through the camera in the game view to see exactly what the player will see. The hierarchy is just a neat list of every single game object in your scene. Down in the project window, that's where all your files live, your art, your sounds, and your code. And the inspector, that's the most important one. You click on any object and bam, the inspector shows you all of its components and settings, ready for you to play with. We've talked about game objects and components, the building blocks, but now let's talk about the most powerful component of all, your own custom code. This is where C# comes in. It's the language you'll speak to Unity to write the rules and give your game objects their own unique brain. Now, here's the absolute game changer. This is the concept that makes Unity so cool. Your code isn't some separate, complicated thing hidden away. A C# script in Unity is just another component. You write the script, and you attach it to a game object, just like you'd attach a physics component. This seamlessly links your logic directly to the objects in your game world. It's incredibly intuitive. So you might be wondering, how does Unity know which part of my code to run and when? Well, you don't actually have to tell it. It's smart enough to automatically look for special methods in your scripts. The 2 big ones you'll use all the time are start and update. Anything inside the start method runs one time, right when the object first appears. Perfect for setting a character's starting health or something. Then you have update, which runs over and over and over again, once for every single frame of the game. This is where you put stuff that needs to happen constantly, like checking if the player is pressing the jump button. Okay, this right here is where you see the beautiful connection between your code and the Unity editor. When you're writing code, if you declare a variable as public, it magically shows up in the inspector in Unity. This means you, or maybe a game designer on your team who doesn't code, can easily tweak things like movement speed or the player's health right there in the editor without ever having to open the script. It is an absolutely incredible workflow. All right, theory's great and all, but let's actually make something happen. It's time to put all these pieces together, the game object, a custom component, and our C# script, to get to that first amazing aha moment in game development, making an object move when you press a key. Making this happen is as simple as 1, 2, 3. Seriously. First, in your project panel, you just create a new C# script. Second, give it a good, clear name so you know what it does. And third, this is the fun part. You just drag that script file and drop it right onto your player game object in the hierarchy. That's it. You're done. The script is now officially a component of that object, ready to give it orders. And this is it. This is the recipe that makes the movement happen. Now, if you're new to coding, don't let your eyes glaze over. Don't worry about understanding every single character right now. Think of it as a set of simple instructions. In just a second, we're going to break down the key ingredients here and see what they actually do. It's simpler than you think. So it all really boils down to three main commands. First, we use input.oxys.getOxys to ask Unity, hey, is the player pressing the left and right keys, or W and S? Then, we use the transform.translate command, which is the instruction that actually moves the game object the script is attached to. And finally, we multiply everything by time.delta. This little bit of magic is so important. It makes sure your character moves at the same speed, whether the game is running on a super fast new computer or an older laptop. It keeps the movement smooth and fair for everyone.
And just like that, you've done it. You've taken a static, boring cube and turned it into an interactive character. You've now grasped the absolute core loop of how things are made in Unity. So, what's next? Well, this is where the real fun begins. Now that you can make things move, you can learn about collisions and make them bump into each other. You can start building menus and health bars with UI scripting. You can even learn how to spawn objects into the world, like firing bullets or creating enemies. Every one of these topics builds directly on top of what you just learned, opening up a whole universe of new things you can create. So, what's the most important thing to take away from all this? It's simple. Don't be afraid to experiment. Don't be afraid to break things, and definitely don't be afraid to see error messages. Every single bug you find and fix is a lesson learned. That's not a setback, it's the path forward. The journey from idea to game starts with that very first game object and that first line of code. So, what are you going to build first?